Hello guys, in this video we will see design of singly reinforced section as per Indian Standard Code IS 456 2000. The method used in this video or design is limit state method. There are two methods for design, that is working stress and limit state. In this design we are using limit state method. There are two cases. First case is section size is given, area of steel to be calculated. In this case, you will have the width of the beam, depth of the beam, but you will have to calculate how much steel you will provide. And case 2 will be section size and area of steel are both to be calculated. Means you will have nothing, no width value, no depth value, also how much steel you will provide you will have to calculate. Case 1, that is section size is given and area of steel to be calculated. We will see the whole design process in a step by step. The step 1 will be calculation of load and bending moment, that is calculation of design and factored load. You can design a section by working or its service load. So you will have to calculate the design or factored load, or also called ultimate load or bending moment. Factored load will be calculated by multiplying the partial factor of safety, that is 1.5. This 1.5 is partial factor of safety, and into working service load, which you will calculate. And in same way you will calculate the ultimate or factor bending moment by multiplying the partial factor of safety into working service bending moment. So when you will have the factored load and factored bending moment, so we will move toward step 2, that is calculation of ultimate moment carrying capacity of the section. This mu limiting is ultimate or maximum moment carrying capacity of the section that the section can take. Okay, then this mu limiting will be calculated by formula. Mu limiting is equal to 0.36 xu max by d into 1 minus 0.42 xu max by d bd square into fck. This formula has came from IS 456 Annex G. If you will see the IS 456 in Annex G, you will find therein, maybe I think that there is in C clause this formula is given, but when you will go to calculate the mu limiting from this formula, it will take so much time. So the simplified version of this formula is mu limiting is equal to q bd square, where q is q in this formula. This formula q bd square has come from this formula, this which you are seeing. This formula I had simplified it for different section, for different means when you will put all the values here, that is fck and xu max by d, when you will put all these values except bd square, then this value will come, that is 0.148 fck bd square for Fe 250 steel, 0.138 fck bd square for Fe 415 steel, 0.133 fck bd square for Fe 450 steel. Q is this thing, these except bd square, and also this you can combine 0.36 fck into xu max d, and this thing in bracket is q except bd. You not have to take bd square. If you will remove bd square, then this is q, and q value is this 0.148 fck bd square for different q value is this for Fe250, q value is this 0.138 FCK for Fe415 and 0.133 FCK for Fe500. From this step you will get your ultimate moment carrying capacity. Okay, mu limiting will be calculated. If bending moment, factored bending moment or ultimate bending moment which you had calculated in step 1 is this bending moment which you have calculated, this bending moment is more than mu limiting which you had calculated in step 2 is if bending moment is more, then section will be designed at doubly reinforced, and converse of this, when there will be bending moment, ultimate bending moment will be less than ultimate moment carrying capacity, then the section will be designed as singly reinforced section. So in this video we are going to design singly reinforced section. So this we are seeing in this video. So step 3, we will move toward step 3. Step 3 is calculation of depth of neutral axis, that is XU. So neutral axis depth can be calculated from bending factored bending moment is equal to moment of resistance of the section. That is, you will have to design a section which can take the factored bending moment, which can resist the factored bending moment, that is singly reinforced section. So bending moment ultimate equal to moment of resistance of the section is what? C, moment of resistance is C into LA, lever arm. So this value is C and this value is LA. This value is C and this value is LA, lever arm. So we will calculate the depth of neutral axis from this formula. Depth of neutral axis will be calculated. Now XU, when XU will be calculated, we will move toward step 4, that is calculation of area of a steel. Now we will calculate how much steel we will require. How much steel means how much bar we will require this. For these you will have to equate compression equal to tension. You know that above the neutral axis the portion is in compression in section, and below neutral axis it in tension, that is equal. So this compression value is 0.36 FCK XU into B for concrete, and tension value is 0.87 FY into AST for steel. So from here AST will be calculated, area of a steel, we will get area of a steel. So when AST will be calculated, your work is done. Means you will now calculate how much bar it will require. Every bar has its diameter, that is 8 diameter by pi degree square by 4. From this you will get your how much bar you will require from here. Now the final step which you need is check for area of a steel, whether the area of a steel lies within permissible limit or not. If the area of a steel will be less than the minimum steel, then it will go to sudden failure, and if the area of a steel will be more than the limiting value of area of a steel, then the section will become over reinforced section. So to avoid this failure and over reinforced section, we check for minimum area of a steel. The formula is given here. AST minimum should be greater than the the AST we will provide will be greater than this value, 0.85 BD square BD by FY will be greater than this value also, and AST which we had calculated should be less than this value, means this value will be greater, means this. When you will calculate this, and this condition when satisfied means AST limiting is greater than AST provided. This is provided. AST provided is greater than AST minimum. Then the section will be safe and your section will be designed.